In today's video, we're going to continue our conversation in our discussion about circles. So we're going to introduce some new definitions that are important going forward with our circles. The first one is tangent, and then we're going to talk about secants and chords. And chords we've already talked about. But we're also going to talk about their relationships of their angles in terms of our circle. So let's talk about that first definition. And the first one is a tangent line. Well, that's a line or a part of a line that intersects a circle at exactly one point. So the example of that in the circle that I have is line CD. So line CD intersects the circle at one point, and the point that it intersects is at point C. So if I have line CD that I'm highlighting, it intersects the circle at point C. All right, the secant. Secant is a line or a part of a line that intersects a circle at 2 points. So my secant, or examples of my secant, is going to be line EB. And that is, let's choose this color. Okay, so line EB is a secant to the circle. And the points, okay, that they intersect are point E and point B. The last one is my chord. All right, and we talked about that last time in the last video. Well, it's a segment whose endpoints are on the circle. And the example, I have two examples of lines that are chords. I have line AC, that's a chord, and I also have line AB. And we know line AB is also a diameter. All right, so I have line AC and AB. Okay, so let's start taking a look at some angles whose vertex are on the circle. And these we've looked at already. So an inscribed angle, which we discussed before, is an angle whose vertex is on the circle, formed by two intersecting chords. So once again, all right, I have a chord AB and I have a chord BC. And the vertex is B. And the relationship between this inscribed angle, X, and the arc that it intercepts, AC, is that it's half the arc. So X equals 1/2. Well, this arc that it intercepts is 100, so 1/2 100, or 50 degrees. Okay, let's take a look at a tangent chord angle. All right, that's an angle formed by an intersecting tangent, which is BC, and a chord whose vertex is on the circle. Okay, and that's going to be AB. Well, the arc that's intercepted by those two lines is 120 degrees. So the relationship, it's going to be 1/2 the intercepted arc. So X is going to equal 1/2 120, or 60 degrees. Now the next one is my tangent radius angle. This one's a little different. It says if a line is tangent to a circle, and this one's really important, it is perpendicular to the radius drawn to the point of tangency. Well, the point of tangency is D. All right, so that's important. Let's give a little different color there. All right, that's the point of tangency. That's the point where the tangent line touches the circle. If I extend the radius So if I extend the radius, let's give, all right, that diameter, well, the intercepted arc there formed by those two lines, it's going to be 180 degrees. So the measure of angle ODB is going to be half, or ODB is going to equal 90 degrees. Okay, 90, well, it's telling you that it's perpendicular, so that should be a big hint that the measure of that angle is going to be 90 degrees. And that's just proof that it is. Okay, angles whose vertex is outside of the circle. This one's a little new. All right, well, the angle formed by two tangents, that's two lines that are touching the circle at one point. So that's going to be AB and BC. So there are two intercepting arcs here, and we call one the major arc, and that's 260 degrees, and then we have the minor. Oh, I don't like that. That looks better. The minor arc, so that's 100 degrees. Well, when that happens, because remember, our angle here is outside of the circle. So our angle is here, outside of the circle. Well, what we do, it's 1/2 the difference of the two arcs. So x equals 1/2. Well, my major is going to be 260 degrees minus my minor arc, which is 100 degrees. And if I put that in my calculator, I know that x equals 80 degrees. All right, now what happens if I have an angle outside of the circle that's formed by two secants? All right, so now, once again, my angle is outside of the circle, and the line that's formed, or the two lines are two secants, both passing through 2 points. All right, it's the same relationship. So it's 1/2, all right, the two arcs subtracted. So I have BD, my minor, and I have AE, my major, and that's E. You can't see it. Anyway, so the measure of x equals 1/2, and that's 80 minus 20. So if you put that again in your calculator, x equals 30 degrees. All right, let's take a look at a couple more on the next page. And the next one is angles formed by a tangent and a secant. Okay, so again, our angle B is outside of the circle, and it's formed by AB, which is tangent to the circle, and BD, which is a secant to the circle. So again, once again, it's outside, and the relationship is going to be AD, the intercepted arc, minus the major minus the minor, which is 30 degrees. So I'm going to write that up. X equals 1/2 100 minus 30, or x equals 35 degrees. Now, what happens if we have angles whose vertex is inside the circle, but not at the center? Before we had inside when we were looking at inscribed, or inside when we were looking at vertical. Well, this one's inside and it's not at the center. So I'm taking a look at trying to find x. All right, and it's formed by BE and ED, but there's a relationship between, all right, that angle and its opposite. All right, kind of think of those as vertical angles. Well, the intercepted arc of both, one is BD, and the other one is CA. What I like to do is I like to think of this as the average of the two. So it's 1/2 of the average of the two arcs. And that's my rule. So x, the measure of x equals 1/2. And when you find an average, you add up the numbers and divide by however many there are. So that's going to be 70 degrees, or 70 plus 170. No, it doesn't matter the order. We're adding. All right. So if I put that in my calculator, 1/2, add those two, 1/2, x equals 120 degrees. Now the last one, an angle whose vertex is inside the circle at the center, we've talked about already. So that's, again, that's a central angle whose vertex is at the center. And we know that x equals the intercepted arc. So x here equals 80 degrees. So let's do a little summary. And something that's very important, it says, obviously this is the summary, memorize. Okay, and there's actually not that many. So if you have the vertex at the center of the circle, well, the measure of the angle is the measure of the angle equals, well, the arc. If you have a vertex inside the circle but not at the center, well, the angle equals 1/2 the sum, or that average. If you have a vertex, okay, that's outside of the circle, and we looked at quite a few of those, the angle measure equals 1/2 the difference. And then the last one, if you have a measure that the vertex is on the circle, well, that is, that inscribed, 1/2 the arc. All right, there is an exception to the rule. We will talk about that during class. What I want you to do, I want you to write down some key ideas. There are a lot. And then I want you to do the check your understanding. That's important. We'll check that in class. And then also remember, write down any questions that you might have. Go Cats, go Knights.